Hey everybody, it's Dr. Skaggs, and this is the YouTube video for minerals. Okay, if you haven't already, please download and print the notes, the skeleton notes. I'm not grading this, it's not something you're handing in, it's just for your own perusal and to study for a minerals and igneous rock quiz, which we're going to have next week on Castle Learning. Okay, so first, let's talk about 5 things. In order for something to be a mineral, it must have these 5 criteria. First thing, it must be natural, meaning that if human beings never lived on the planet, never walked here, you could find it here. It must be inorganic. So at no point has any part of the mineral ever been living. If you find one little shell in it, a shell fragment, then that is considered organic. It is living material. Okay, so you don't want to be organic at all. Solid, must be solid. Hopefully you know the definition of something that's solid. It has a specific crystalline structure, such as these over here, which you do not need to memorize, but that pattern will be found throughout the mineral, a specific arrangement of atoms. We're going to talk about that atomic arrangement in a little bit. And it has a definitive chemical composition. Okay, so it must have all 5 of those things. Composition, meaning what is it made out of? Ice is made of H2O, all right? That'd be the chemical composition of ice. And ice is a mineral, by the way. It does satisfy all 5, right? It is natural, it was never living, it is solid. It has a specific arrangement of atoms. And the chemical composition. Now, once you know it's a mineral, we can classify it several ways. One way, but which is not a great way, is color. Okay, mainly because color, you can find many different colors for the same mineral. These are all pictures of quartz. Okay, look at all the different types of quartz. We've got rose quartz, we have something called amethyst, we have something called smoky quartz, you have a very beautiful clear quartz, you have an opaque quartz. So these are all different kinds of quartzes. So, and there's even more than that. That's just a few of them. So you can't say, well, this mineral is quartz because it's white. Well, because quartz can also be purple or blue or rose or black or whatever. And conversely, you can't say, well, this one particular mineral is talc because it's white. Why? Because many minerals are white. So color is a really, really poor way, and they have asked that in the past. What is the least definitive way of defining a mineral? That would absolutely be color. Streak, you might remember this from 6th grade. I think some of you may have taken a streak plate and taken a mineral and done one of these things to it, where you scratched the mineral up against the surface and you left a powder behind. And that's called streaking a mineral. Okay. And this is definitive for a mineral. Okay, this will not change. So all those different colors of quartz I just showed you, they will all streak with the same white powder. Okay, and every mineral will only have that one specific color, whatever it may be. It's not always white. It may be something else. Another way of defining a mineral or classifying a mineral is its luster. Okay, so luster is simply how shiny it is. If you have something that looks like it's made out of metal, like this right here, that is pyrite. Look how shiny metallic that is. Or you have something that's more of a dull finish to it, and that is what we're going to call non-metallic. Okay, now there are more lusters than these two. If you go into college, I always laugh when I say that. But we're only going to deal with 2 simple ones, and we only have a handful of shiny metallic ones. So if it's either shiny, then it's metallic. If it's not shiny, then it's going to be non-metallic. Then we have hardness. I love some of these terms I have to teach teenagers. Hardness is its resistance to being scratched. Okay, so you can only scratch a mineral with a mineral that is harder than it. And as far as the Regents is concerned, they're really just concerned whether it could scratch glass or not. So is it harder than glass? Well, you take a mineral and you just scrape it right across. If you hear that grinding sound and it leaves a scratch right across the glass, then that mineral is harder than glass. If it leaves nothing and you don't hear that grinding sound, then it is not harder than glass. And like I said, you can only scratch things that are harder than the other. Let's see. Hardness scale is right over here. This was developed. This is called Mohs scale. It goes from 1 to 10. And as you can see, the hardest mineral is diamond. They do like asking about diamond a lot because it is the hardest mineral. And it goes from 1 to 10. Okay, so hardness. Then we go to our old favorite. It never goes away. Density. and this will never change for a specific for any mineral. Okay, a mineral each has its own density. A piece of quartz, a big cobble of quartz would be 2.7 grams per cubic centimeter, or a tiny little pebble of quartz would be 2.7 grams per cubic centimeter. And that's one of the ways that they determine that mineral you saw before, that pyrite, was not real gold. They would just take the density of it, and density of gold is a lot more than pyrite. Another wonderful earth science term, cleavage and fracture. This is purely how a mineral breaks, okay? Not how it grows, how it breaks. Now, ironically, if it breaks with a flat surface, then it is said to have cleavage. And look at the flat surfaces on this. And usually what you're going to do is you're going to take a mineral and you can kind of move it around. And if you see one surface reflect light back on it, then it's considered having cleavage. And if you see these rough edges, then it's considered having fracture. If you have trouble, don't want to do, or so that. If you have trouble remembering these, then something that I normally do, I think about a fracture in a bone. Right? Yeah, let's look at this guy right here. Rarely or never does a bone ever fracture with a flat surface. So fracture is rough, cleavage is flat. Another way of classifying minerals is crystal structure, and this is talking about the arrangement of atoms. Now you see I have 2 stars here. This is extremely important. They ask it very, very commonly. What property of a mineral is responsible for its boiling point, for its cleavage, for its fracture, for its streak, for its luster? And that is all its arrangement of its atoms. Okay, the way the atoms are arranged determines all these chemical and physical properties. They ask it many, many times. Sometimes they'll say atomic arrangement, and that's the same thing. Okay, and that's these things over here, which I showed you before, again, which you don't have to memorize. A few other things I have here listed. Number 8, something called an acid test. And the flexibility. If you look at this picture over here, there's some hydrochloric acid, and we put a few drops on it on this mineral, and you can see how it's bubbling and fizzing. And there's a couple minerals that do that, calcite and dolomite. Write down calcite because they seem to love to ask about calcite. It is on the reference table. I'm going to get away from the practice for a little bit. There's still a few more notes I want to talk about. The processes that create minerals. These are all practice ones that we'll talk about in a little bit. The processes that form minerals, okay, is called crystallization and recrystallization. So if you see those terms anywhere, they are talking about minerals. Okay, so minerals formed by that. And something else. Now I don't think I have it. Yeah, I do have here. Minerals are made up of one or more elements. Okay, please do not get the terms elements and minerals confused. Kids burn through these questions, and when they're not reading the question correctly, sometimes they're asking for elements. What elements make up a mineral? You look them up. It's right on the reference table. Or they may say, what minerals make up this rock? They ask for minerals versus elements. Please be careful. And oddly enough, the same 8 minerals make up most of the rocks on the earth. So most of the rocks are made up of just 8 minerals. I mean, that's pretty crazy to think about. A few extra facts I have down here underneath my skull thing right here. There we go. Each person is going to use, every one of you, should you live a normal life into your 70s or 80s, will use 3.5 million pounds of minerals. It's kind of crazy to think about that. The last 2 spots on the notes is the second bullet point, and notice it is capitalized. This is most likely going to be on the quiz or my test or the Regents. They love letting you know that most of these minerals are limited and not renewable. So once they're used up, that's it. We can't make more of them, okay, and they're gone. Fossil fuels and coal. Well, actually, would you think coal is a mineral? Think about that one, and I'll come back to that at a later point. But certain things, again, once they're gone, they're gone. Other okay, how we use these minerals are based on their properties. You're not going to use a really soft mineral to make a countertop. New York we produce a lot of cement materials such as sand, gravel, and salt. So we'll use those in various things. Environmental issues in extracting these resources will destroy the environment. Harvesting these, it creates a lot of pollution taking rid of these. And again, resources are not renewable. Okay, that's all I got here for you today on minerals. Check back the other link and we'll start going over igneous rocks. Okay. Okay. And trying to pause. Okay.